We're now going to talk about another aspect of experimental design that doesn't necessarily tie directly in with statistical hypothesis testing, but is nevertheless important for ensuring you make the correct inference from your data. Here we're going to talk about experimental controls, how they can be really useful in ensuring that your data, and hence your statistical analyses, are really trustworthy. An experimental control is an extra treatment added to your experiment where you know beforehand what the outcome or measurement should be. And this can be instrumental in figuring out why an experiment didn't work out correctly, or if any new or potentially exciting results you find are trustworthy. Now, broadly speaking, controls come in two forms. A positive control is a treatment where if the experiment is performed correctly, there should always be an observed positive result. And in contrast, a negative control is a treatment where if the experiment is performed correctly, there should be a null result or nothing should happen. Positive and negative controls are really going to be specific to your system. But a positive control I might use, say if I were screening bacterial isolates for antibiotic resistance, I might also include a strain I already know to be resistant to that antibiotic I'm screening. If I find that none of my new strains grow on the antibiotic medium, I can then check whether my known strain also grew. And if it didn't, that might let me know that there's something wrong with the medium I produced. Maybe I put too much antibiotics in, or maybe I didn't put in the correct sugar that the bacteria need to eat in order to grow. Another example, if I were measuring the production of some enzyme produced by one of my strains, I might include a sample without bacteria where I spike in a known amount of that enzyme. If the reaction I'm looking for doesn't occur, then it suggests some aspect of the assay design to measure the production of this enzyme is ineffective. For negative control, it's very common for me to include a test tube with growth medium that has no bacterial cells inoculated into it. My inspected result in this case is that if I put no bacteria in, nothing should grow and the medium should remain clear. A cloudy tube, in contrast, would be an unexpected result, which could indicate that there was something wrong. Maybe my growth medium was contaminated with bacteria, and therefore I shouldn't trust the results from my experiment. Another negative control you might have come across if you do lots of PCR is to spike all of the PCR reagents into the reaction, but add no template DNA. In this case, I should expect to see no DNA amplification occur. But if I do observe it, that might indicate in some way that my reagents were potentially contaminated, and maybe I should throw them away and get fresh ones from the freezer. As I said before, these are very specific examples, and you'll have to consider for yourself which sorts of positive and negative controls would be appropriate for your own system. Just a brief note now on developing and testing new experimental designs. Anytime you do anything for the first time in the lab, it's often really useful to do what we commonly refer to as a pilot experiment. And this is a shorter or smaller version of your planned experiment that allows you to test or refine the protocol that you've either been given or have developed. For example, if you're going to run a multi-day experiment, do it maybe just for the first few days. Don't plan the next month or two of your life without having done a trial run first. Maybe if you have lots of really expensive reagents or samples, maybe you want to test your protocol on just a few before you dive in and do all of them all at once. This lets you work out any kinks in your protocol that you might not have accounted for when you were planning out your experiment, either on the whiteboard or in your head.